Assalamualaikum and good day to everyone. Today we're going to have a look at two component system, two completely miscible liquid and also how to use Roth law to calculate the vapor pressure of the mixture. Two component system is made up of a mixture of two chemically independent species. The mixture may be of homogeneous or miscible liquid, then we form a single phase. For example, a mixture of nitrogen gas and hydrogen gas, a solution of methanol in ethanol, and alloy of copper in tin. Second one is heterogeneous or immiscible liquid. There we form two separate liquid phases. Example, suspension of oil in water. Now we have a look at definition of miscibility. Miscibility is the ability of liquid mixture component to mix with each other. There are three types of miscibility. The first one is miscible. Liquid form a homogeneous mixture and mix completely to form a single phase. For example, the mixture of ethanol and water. As you can see here, there are no separate boundary. The second one is partially miscible, result in a distinguishable mixtures between the liquid. The volume is not identical to the original volume. For example, the mixture of ethanol and water. The last one is immiscible. The liquid cannot mix together at all. The volume is the total volume of liquid added originally. For example, the mixture of oil and water or the mixture of water and hexane. So as you can see here, partially miscible, you can see the separate boundary, and then for the immiscible, you can see the separate boundary. Solution and Roth law. A solution is a homogeneous mixture made up of solute in a solvent. A solution made up of two liquid components may be ideal or non-ideal. Roth law, the law that classifies solution as either ideal or non-ideal. The example of ideal solution is methyl alcohol, the mixture of methyl alcohol and water, mixture of benzene and toluene, and mixture of methanol and ethanol. Some example of non-ideal solution or real solution is the mixture of ethanol water, the mixture of isopropyl alcohol and water, the mixture of propanol and water, and the mixture of chloroform and ethanol. Roth law. Roth law only works for ideal mixture. The law states that the partial vapor pressure of component A is equal to the product of its mole fraction in solution and the vapor pressure of pure A. This is similar for liquid B. So the equation for liquid B will be partial vapor pressure for liquid B equal to the mole fraction for component B times with the vapor pressure of pure B. The mole fraction for component A is equal to the number of mole for component A divided by mole of component A plus mole of component B. Meanwhile, for mole fraction for component B equal to the mole of component B divided by mole of component A plus mole of component B. Therefore, the total pressure of mixture of ideal gases is the sum of the partial pressure of the gases mixture. Okay, the equation will be P total equal to partial vapor pressure of component A plus partial vapor pressure of component B in a solution equal to mole fraction of component A times vapor pressure of pure component A plus mole fraction of component B times with vapor pressure of pure component B. So when mole fraction for component B is equal to 0, P will be equal to mole fraction of component A times vapor pressure of pure component A. And if mole fraction of component A is equal to 0, P will be equal to the mole fraction for component B times with vapor pressure of pure component B. And always remember, the total mole fraction in a system is always equal to 1, which is mole fraction of component A plus mole fraction for component B equal to 1. Ideal solution. Ideal solutions are formed when the solute and solvent have similar structure. Example, the mixture of benzene and toluene. So they have almost similar structure. In a mixture of miscible liquid of A and B, there are three types of intermolecular forces between the molecule, which are the attraction between AA, BB, and AB. In ideal solution, intermolecular attraction between like molecule and unlike molecules are equal in strength, which is the forces between AA is the same as AB or BB. There is no change in the energy. Delta H solution is equal to 0 and the volume of solution is equal to 0. So maknanya the total volume of solution A and B when mixed remain unchanged. For example, 50 ml of A when added to 50 ml of B will give 100 ml of solution. By applying delta law of partial pressure of a component is equal to mole fraction times total pressure. So let's say YA and YB represent the mole fraction of component A and component B in the vapor phase respectively. P equal to PA plus PB, hence the mole fraction of component A in the vapor is given. YA equal to partial pressure of component A divided by P total equal to partial pressure for component A divided by PA plus PB. So the mole fraction of component B will be YB equal to PB divided by PT. So PB divided by PA plus PB. So this YB and YA is the mole fraction of component A and component B in the vapor phase. Now we have a look at example. At 40 degrees Celsius, the vapor pressure of heptane and octane are 92 mm mercury and 31 mm mercury. The mixture of heptane and octane forms an ideal solution. A mixture of heptane and octane containing 35% heptane is placed in a closed vessel. Number 1. From the above situation, predict the more volatile component. The more volatile component is the one that has higher vapor pressure, which is heptane, with value 92 mm mercury. The second one, calculate the total pressure of the vapor formed. In order to get the total pressure, you need to sum the partial pressure of component A and the partial pressure for component B. Partial pressure for the component A will be mole fraction times vapor pressure of component pure A, and the partial pressure for component B equal with mole fraction of component B times with partial vapor pressure of component B. So mole fraction for A, which is heptane, equal to 0.35. Mole fraction for B, which is octane, equal to 0.65. Always remember, the mole fraction for A plus mole fraction for B must equal to 1. So to find the total pressure of the vapor, you need to find the partial pressure for A and the partial pressure for B. That will be 0.35 times 92. This one is partial pressure for A, and then for partial pressure for B, 0.65 times 31. So the total pressure will be 52.35 millimeter mercury. The last one, calculate the vapor composition of octane in equilibrium of the solution. So in order to calculate the vapor composition of octane, you need to apply the law of partial pressure. That will be the mole fraction octane equal to the partial pressure octane divided by the total pressure. So equal 0.65 times 31 divided by 52.35. So the vapor composition will be 38.5%. Second example, mixture of ethanol and methanol form an ideal solution. At 20 degrees Celsius, vapor pressure of ethanol and methanol are 44.5 mm mercury and 88.7 mm mercury. A solution containing 5 mol of ethanol and 3 mol of methanol is allowed to vaporize in a closed vessel until equilibrium is reached. A. Determine the component that is more volatile. More volatile component is the one that has higher vapor pressure, which is methanol with 88.7 mm mercury. B. Calculate the total vapor pressure in millimeter mercury of the solution. The first thing you need to find the mole fraction of ethanol, which is equal to mole of ethanol divided by total mole. So this total mole is equal to ethanol plus methanol equal to 5 mole divided by 5 mole plus 3 mole equal to 0.625. So now we can calculate mole fraction of methanol, which is equal 1 minus 0.625 equal to 0.375 mole. So always remember the mole fraction of ethanol plus mole fraction of methanol must equal to 1. Then you can find the partial pressure for ethanol, which is equal to mole fraction ethanol times vapor pressure pure ethanol equal to 0.625 times 44.5 mm mercury equal to 27.8125 mm mercury. So the partial pressure of methanol is equal to the mole fraction of methanol times with vapor pressure of the pure methanol equal to 0.375 times 88.7 mm mercury equal to 33.2625 mm mercury. So the total vapor pressure will be partial pressure of ethanol plus partial pressure of methanol equal to 27.8125 plus 33.2625 mm mercury equal to 61.075 mm mercury.